According to the National Electrical Code, both normal and life safety power circuit wires can be installed through the same row of fixtures, but it is crucial that they remain separate within the fixture itself. This separation mandates the use of distinct compartments or raceways within the fixture to house each set of wires, preventing any contact between them. The NEC emphasizes the importance of life safety circuits maintaining their reliability and operability during emergencies. To achieve this, these circuits must be shielded from potential damage and interference, enabling them to function independently from the regular power circuits. By maintaining this physical separation of normal and life safety power circuit wires within the fixture, it can be ensured that the life safety circuits will continue to function properly during an emergency, even if the normal power circuits are compromised. This requirement aligns with the broader goals of the NEC, which seeks to establish minimum safety standards for electrical installations to safeguard people and property from hazards associated with electricity. When installing normal and life safety circuits, understanding the relevant articles and sections within the NEC is important. Firstly, Article 700 addresses emergency systems. It provides comprehensive guidelines for the installation, operation, and maintenance of electrical systems intended to supply power automatically to designated areas and equipment in the event of failure of the normal power supply. Secondly, Article 701 covers legally required standby systems. These systems are designed to supply power to specific loads, such as heating, ventilation, and air conditioning systems, when the normal power supply is interrupted. Thirdly, Article 702 pertains to optional standby systems. These systems are installed at the discretion of the owner or user to supply power to non-essential loads during a power outage. When separating normal and life safety circuits within a lighting fixture, several methods can be employed. One approach is to use separate raceways within the fixture. This involves installing two distinct raceways, one for the normal power circuit wires and another for the life safety circuit wires. The raceways must be securely fastened to the fixture and properly grounded. Another option is to utilize barriers or dividers within the fixture. These barriers or dividers physically separate the normal and life safety circuit wires, preventing them from coming into contact with each other. The barriers or dividers must be made of a non-conductive material and securely fastened to the fixture. Another strategy involves using listed and labeled wiring methods specifically designed for separating normal and life safety circuits. These wiring methods typically incorporate features such as insulated conductors, grounded shields, and physical barriers to ensure adequate separation. Proper grounding is also essential for both normal and life safety circuits. Grounding provides a low impedance path for fault currents, helping to protect against electrical shock and equipment damage. The grounding system must comply with the requirements of Article 250 of the NEC. Maintaining separation between normal and life safety circuits is not only important within the fixture itself, but also throughout the entire electrical system. This includes ensuring that normal and life safety circuits are run in separate conduits or cable trays, and that they are not mixed together in junction boxes or panels. Regular inspections and testing are also necessary to verify the integrity of the separation between normal and life safety circuits. These inspections should be performed by qualified electrical personnel and should include visual inspections, continuity tests, and insulation resistance tests. It is important to note that the specific requirements for separating normal and life safety circuits may vary depending on the application and the local electrical codes. Therefore, it is always essential to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable regulations. Failure to properly separate normal and life safety circuits can have serious consequences, including electrical shock, equipment damage, and the failure of life safety systems during an emergency. By following the guidelines outlined in the NEC and other applicable standards, it is possible to install normal and life safety circuits in a manner that ensures their safety and reliability. Firstly, always consult the local electrical codes and regulations. These codes may have specific requirements for the installation of normal and life safety circuits that are more stringent than the NEC. Secondly, use qualified electrical personnel for all electrical work. Qualified electricians have the knowledge and experience necessary to install normal and life safety circuits in a safe and compliant manner. Thirdly, carefully plan the installation of normal and life safety circuits. This includes determining the appropriate wiring methods, raceway systems, and grounding methods. Fourthly, inspect all materials and equipment before installation. Ensure that all materials and equipment are in good condition and are approved for use in the intended application. Fifthly, install all wiring and equipment in accordance with the manufacturer's instructions. Failure to follow the manufacturer's instructions can void the warranty and may create a safety hazard. Sixthly, test all wiring and equipment after installation. This includes performing continuity tests, insulation resistance tests, and ground impedance tests. Seventhly, document all work performed. This includes keeping records of all materials and equipment used, the wiring diagrams, and the test results. Eighthly, maintain the electrical system in good condition. This includes performing regular inspections, testing, and maintenance. Ninthly, provide training to personnel who will be working on or around the electrical system. This training should cover the hazards of electricity, the proper safety procedures, and the operation of the electrical equipment. Tenthly, develop an emergency plan in case of an electrical failure. This plan should include procedures for shutting down the electrical system, evacuating the building, and contacting emergency services. Furthermore, when dealing with emergency lighting circuits, there are several critical factors to consider. Firstly, the emergency lighting system must be designed to provide adequate illumination for egress routes and other critical areas during a power outage. The level of illumination should meet the requirements of the applicable building codes and standards. Secondly, the emergency lighting system must be powered by a reliable source of power, such as a generator or a battery backup system. The power source must be capable of providing power for the required duration, typically 90 minutes or more. Thirdly, the emergency lighting system must be automatically activated upon failure of the normal power supply. This can be achieved using a transfer switch or other automatic switching device. Fourthly, the emergency lighting system must be regularly tested and maintained to ensure its proper operation. This includes testing the battery backup system, inspecting the lighting fixtures, and replacing any faulty components. Fifthly, the emergency lighting system must be installed in accordance with the applicable electrical codes and standards. This includes using approved wiring methods, grounding the system properly, and providing overcurrent protection. In addition to emergency lighting, life safety systems often include fire alarm systems. Fire alarm systems are designed to detect fires and alert building occupants. These systems typically include smoke detectors, heat detectors, and manual pull stations. The fire alarm system must be connected to a central monitoring station or the local fire department. The fire alarm system must be regularly tested and maintained to ensure its proper operation. This includes testing the detectors, inspecting the wiring, and replacing any faulty components. The fire alarm system must be installed in accordance with the applicable fire codes and standards. Another critical aspect of life safety systems is emergency communication systems. These systems are designed to provide communication between building occupants and emergency personnel during an emergency. Emergency communication systems may include two-way radios, public address systems, and emergency telephones. The emergency communication system must be powered by a reliable source of power, such as a generator or a battery backup system. The emergency communication system must be regularly tested and maintained to ensure its proper operation. This includes testing the radios, inspecting the wiring, and replacing any faulty components. The emergency communication system must be installed in accordance with the applicable codes and standards. Proper documentation is also crucial for life safety systems. Detailed records should be kept of the design, installation, testing, and maintenance of all life safety systems. These records should be readily available to emergency personnel and building owners. The documentation should include wiring diagrams, equipment specifications, test results, and maintenance schedules. Regular training is also essential for building occupants and emergency personnel. Building occupants should be trained on how to use the life safety systems and what to do in the event of an emergency. Emergency personnel should be trained on how to operate the life safety systems and how to coordinate emergency response efforts. The training should be conducted regularly and should be updated as needed. When installing and maintaining life safety systems, it is important to consider the specific needs of the building and its occupants. The life safety system should be designed to address the unique hazards and risks associated with the building. The system should also be designed to be accessible to people with disabilities. Furthermore, it is crucial to coordinate the installation and maintenance of life safety systems with other building systems such as HVAC systems, plumbing systems, and electrical systems. This coordination helps to ensure that the life safety systems will function properly during an emergency. In addition to the NEC, other standards and guidelines may also apply to the installation and maintenance of life safety systems. These standards may include those published by the National Fire Protection Association, the International Code Council, and other organizations. It is important to be familiar with all applicable standards and guidelines. The goal of life safety systems is to provide a safe environment for building occupants in the event of an emergency. By following the guidelines and recommendations outlined in this narration, it is possible to install and maintain life safety systems that will protect people and property from harm. Firstly, identify all potential hazards and risks. Secondly, design the life safety systems to address those hazards and risks. Thirdly, install the life safety systems in accordance with applicable codes and standards. Fourthly, test the life safety systems regularly to ensure their proper operation. Fifthly, maintain the life safety systems in good condition. Sixthly, train building occupants and emergency personnel on the use of the life safety systems. Seventhly, document all aspects of the life safety systems. Eighthly, coordinate the installation and maintenance of life safety systems with other building systems. Ninthly, stay up to date on the latest codes, standards, and technologies related to life safety systems. Tenthly, consult with qualified professionals when necessary.